Adrian, the hyperMILL MAXX machining process. I've heard so much about it, but this is the first time I've actually seen it. Can you tell us a bit more?
Okay, so the hyperMILL MAXX machining comes in three different areas. It starts from drilling, then roughing, and then finishing.
And we hear some ridiculous cycle time savings. Can you give me some examples?
Yes, certainly. On these, particularly this part you see in the background, it has some very flat walls or curved surfaces. Now the corner radiuses are very small, which means that typically you would have to machine them with ball mills. In this particular example, we're using a conical barrel tool. This is an open mine unique speciality, and we're cutting this face, you can see in 5 axis. Using this tool with a very large radius enables us to have very big stepovers.
And I can see this is great for aerospace. This could be any number of components, couldn't it? But what other sectors would possibly embrace this?
I think anything that you really want to look at, not the industry, but the actual surface. So the geometry. So anything to start with, anything with a flat face in mold and die or medical. Or it could be water pumps. It could be really any area. If it's got a flat face, then we can utilise the barrel finishing process and machine those surfaces.
Some of the strategies look incredibly complex. How's the programming?
This is the interesting thing, because we always say if it's not easy to use, then you won't use it. But in the case of this tangential barrel machining, you pick the face, you pick the tool, you calculate. Everything is taken care of. It really is super easy to machine this, and in fact, it's probably easier than cutting a 2D or 3-axis surface.
So I don't need to be an advanced user?
Absolutely not. Once you get over the certain process of how you utilize this tooling, the step over, the quality you need, it really is a simple process of getting the result that you need.
The helical drilling fascinates me.
Yeah, certainly it's a nice process for punching a hole into material. The interesting net result from this type of strategy is the more difficult the material, the bigger the benefits you'll see. So if you're starting to machine things like titaniums or Inconels, then you can really utilize this tooling and punch big holes into pockets very, very quickly and get a good performance from tools that really aren't even meant to be center cutting. So by leaning the tool forward and spiraling into material, the load on the spindle is much reduced, and you can push it a little bit harder.
How about my tool life?
Absolutely increased, because because you're tipping the tool forward, you're cutting on the front end of the tool, and it's very similar if you've ever inclined a tool forward and tried to machine a flat face. You get a much nicer surface quality because the back end of the tool is not touching material, and so better surface quality, better surface tool life.
And it's a similar argument for process reliability, I guess.
Yeah, absolutely. I mean, you can see the part behind me is sticking a long way out of the vise. It's a nice Lang vise system. But would you really want to be punching a hole on the end of this part with, say, an 80 or 100 mil U-drill? This process is safe. You can utilize it from holes from, let's say, 1.5 times diameter of that tool, or up to how big a hole you want to machine. So if I was machining and I wanted to machine a 100 mil hole, I wouldn't be putting a U-drill on this type of setup.
So you've got thousands of hyperMILL users in the UK. Can anyone adopt this technology?
Absolutely. As long as you have a 5-axis machine, it doesn't matter if it's very dynamic, like this hyperMILL C42 behind me, or let's say a little bit non-dynamic, a big, say, gantry style machine. This process is good for both types of machine tool.